Alright, so in class on 6.6, you were asked to actually do this on your own, kind of a student exploration thing, where you would look on Desmos and kind of try and figure some of this out. So I'm just going to kind of go through kind of speed. You'll see what's going on, really what we're trying to get at. The degree of the polynomial is always the highest. So the degree is always the highest exponent. So in this case, it's 3. Okay, the highest degree, cubic if you prefer. How many x-intercepts? The x-intercepts are always tied into the exponent. Whatever the exponent is, there should be that many either evens or odds. Well, you're going to see kind of what happens here. But I would expect 3 because it's based on the x-intercepts. They're the roots, they're the zeros, there's the solutions. Now sometimes when you do those, you get I in an answer. I is imaginary, so it's not going to actually show up as a root. And that's actually what happens on this graph. There's a point at -1, 0 that works, and then there's a point at 0, 4 that works, and your graph kind of looks something like that. Okay, and it's just a sketch, so it's going to kind of look like that if you were to graph it in Desmos. And if you look at it, of course, you can see there's really only one x-intercept. And that x-intercept is at x equals -1. This is your A from the previous sections. Okay, so now that we found the x-intercept, of course we're rewriting this again, we're going to use synthetic division, so we're going to divide -1 in. I know that when I do this, I kind of put a bar over it like this. Miss Kendra does it a little different, nothing wrong with that. We drop it low on the first term, multiply, add, multiply, add, multiply, add, and the resulting polynomial, remember this is remainder, number, x, x squared, which makes sense. Again, we're pulling in x, -1 out of x cubed, and we're left with, well, x squared plus 4. That's my resulting polynomial. Okay. Now from that, what are the solutions? Again, the solutions mean, and I underline both of these intentionally, to set the terms equal to 0. So I've got x squared plus 4 equals 0. And I know what a lot of you are thinking, x minus 2x plus 2. But that only works when there's a minus sign right there, not a plus sign. So to solve this, I would just minus 4 to both sides, and then square root it, and I get x equals, remember anytime we take a square root it's plus or minus, and this is 2i, because this is the square root of 4 times the square root of -1. Okay, square root of 4 is 2, square root of -1 is I. Now again, what that means is I have two solutions. These solutions are also called my zeros, and I said because again we're setting that equal to 0. So what I have here again is 2i and -2i. Maybe I should rewrite this as 2i and -2i. So I'm going to plug in x minus 2i as a factor, x minus -2i as a factor, which becomes plus. And so given those factors, those are my imaginary roots. That kind of brings me to the imaginary root theorem, which says if a plus bi is a root, then a minus bi is also a root. Okay? These are called complex conjugates. Are we going to test you on that? No, but not a bad thing to hear because I'm going to say it again. Let me give you an example. I've got x cubed minus 9x squared plus 33x minus 25. And I'm telling you that a equals 1 is a solution. So I'm going to synthetically divide it in. Hopefully by now you recognize what synthetic division is, the dividing thing we've been doing. Drop it low, multiply, add, multiply, add, multiply, add. I should get 0 because I told you I knew it was a solution. This gives me x squared minus 8x plus 25. And that is not factorable. So if I set that equal to 0, I can't factor it because there is no factors of 25, which are 5 and 5 or 25 and 1. That will add up to give me 8. So I need to use the quadratic formula. A is 1, B is -8, and C is 25. I'm not going to ask you to do this. I'm telling you how it works. When I plug it into the quadratic formula, I do the opposite of b, plus or minus the square root of b squared minus 4ac, which is 100, all over 2a, which is 2. And I'm doing this fairly fast. This is -36, and the square root of that is 6i, so I get plus or minus 6i all over 2. And 2 goes into each of those. We can simplify it to give me 4 plus 3i and 4 minus 3i. goes into there to give me 4, goes into there to give me 2, the 2 would go away. Plus or minus means the plus and the minus right here. So I have, again, 2 solutions here. 4 plus 3i, 4 minus 3i. So if that's a root, then that's a root. That's how it works, okay? And of course, x equals 1, excuse me, not negative 1 as well, because that was given initially. Now here, again, there are 3 solutions because exponent equals 3. The exponent is the number of solutions. It works that way all the time. Let's go to the next page. Very similarly, we're going to set up this page by first talking about what's the degree. Well, again, it's 3 because the highest exponent is 3. That would expect to get 3 x-intercepts. And on this one, if you plug it into decimals, you would see, first of all, that there are 3 x-intercepts, and the value of the first one is 2. And if I plug 2 in, I'm going to get like a square root number. Here, I'll show you what it looks like. 2 into 1, negative 2, negative 5, and 10. I get x squared minus 5. Now we're going to actually see that down here, so I'm not going to keep going on that. But when I square root that, I get 2.236. And if you look down decimals, that's actually the value, is plus or minus 2.236. Okay? Now where does that line up? Well, 2 is here. 2.236 is probably closer to that than that, but I don't have room, so I'm just going to kind of put it there and there. Now if you remember, when it's an odd, we start down and up. So I need to start down here, go through that point. All of them are odd roots, so I go through that point, and then I come back through that point. And there's my graph. It started down, it ended up, we look good. When I synthetically divide it, well, I already kind of did that. I got a little ahead of myself, so I'm just going to copy those numbers in here. What is that polynomial? Well, I already did that too. X squared minus 5. The solutions, well, let me go back up here. No, I'm sorry. I entered this down here, but I'm going to come back up here and set that equal to 0. I would add 5 to both sides. X squared equals 5, and when I square root it, I get x equals plus or minus the square root of 5, which, by the way, is how I got those 2 numbers. Okay? Now, with that being said, these are the, again, zeros, the roots, the solutions, any way you want to think about it. So we can write the resulting polynomial as x minus the square root of 5 and x plus the square root of 5. And those are called irrational roots. They're irrational because I can't multiply anything and get that number. All square roots, unless they're perfect squares, are irrational. What this says, similar to the previous page, is if a plus the square root of b is a root, then a minus the square root of b is also a root. And those are called simply conjugates. They're not complex because they don't have the I in them. Okay? Let me give you another example of that. X cubed minus 4x squared minus 5x plus 14. I'm telling you a equals negative 2 is a solution. So we're going to plug negative 2 in synthetically. And remember, drop it low, multiply, add, multiply, add, multiply, add. This gives me x squared minus 6x plus 7. And if I set that equal to 0, you're going to think, oh, I can factor that because 7 and 1 gives me 6. Except, no, sorry, I need to move that up. I'll give you a second to copy that and pause it if you need to. Now, again, except when I do this, I'd have to have negative 7 plus 1. That would give me this. But negative 7 times positive 1 would not give me a positive 7 here. So again, I got to go to the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now this again is square root of 8, which is square root of 4 and square root of 2. So I get 6 plus or minus 2 square roots of 2 over 2. The 2 divides into there, and I get 3 plus or minus the square root of 2. Well, what that means is x equals negative 2. That was my first solution. 3 plus the square root of 2 and 3 minus the square root of 2. Those are my, again, 3 solutions because it's to the 3rd power. They're not always real. They could be imaginary, or they can be real. And if you look at this graph, they all showed up, but they're kind of weird values. That can happen. That's what the irrational root theorem says. Next page. So what does all this mean? That means that if I'm given these roots, what are the other roots? Well, anytime I see a square root or an I also need to include its opposite. So 7 minus 5i, square root of 5 is 1, and 2i is also 1. But not negative 3, because that doesn't have an I or a square root attached to it. This is going to be, of course, 2 plus 7i. This gives me 4 minus 5i. Those are also roots. So this would be a 4th degree. This would be a 5th degree, because there's 5 solutions. Excuse me, on this one, 7i would work, 2 minus the square root of 10, and 1 plus 6i. So this would be a 6th degree. Let's write that down. Because, again, there's 6 solutions. This would be a 4th degree. This would be a 5th degree. Because, again, whole numbers by themselves do not get, integers, excuse me, do not get the opposite. So when I'm going to write these degrees, these polynomials down here, it says you may need to find additional roots. And what I mean by that is, again, if I have square root of 2, then I also must have the opposite of that. If I have negative 4i, then I also should have 4i. If I have 5 plus 2i, I should also have 5 minus 2i. Now we're not going to do this one. I just want to give you an idea that I also have to have that. It's crazy difficult. You don't want to see it. Okay? But for the other two, when I'm given the roots, you had to do this in 6.1b. You can write this as x minus square root of 2, x minus 4, and x minus negative square root of 2, which of course changes to a plus. And what I always want to do is I want to put the opposites by each other, and you're going to see why. X minus square root of 2, x plus square root of 2, x minus 4. FOIL this out, x squared minus square root of 2x plus square root of 2x cancel each other out, minus square root of 4. Okay? Maybe I'm going too fast. Let me go minus times x plus square root of 2 times x minus square root of 4, because I'm multiplying what's inside with what's inside. Still get that x minus 4 here. These will cancel. Square root of 4 I know is 2. So I've got x squared minus 2 times x minus 4. And again, if you put those roots together, now it's just a simple FOIL problem. First, outside, inside, last. Done. This one is very similar. I've got x plus 4i. I've got x minus 13, but I'm going to write this over here because I'm just going to save myself a step. And then x minus 13. Again, it's always x minus, and it's minus a negative, which is what gives me the plus. These two will FOIL out to give me x squared minus 4xi plus 4xi. If you wrote ix or I4x or any of those, it's correct as well. Minus 16i squared times x minus 13. Now something should be triggered. First of all, these are opposites, they cancel. Right here I've got a negative 16 times a negative 1, because I squared is negative 1. Well, that gives me a positive, so I get x squared plus 16 times x minus 13. And again, it's a FOIL problem, very simple. X cubed minus 13x squared plus 16x minus, I'll do the math for you, 208. Again, we're skipping number 6. It's not going to be, it's in your homework, don't do that problem. Okay? Down at the bottom here, 7 and 8. These are, find all the roots. It's kind of a review of what were the possibilities. Remember, the possibilities here again are the factors of this divided by the factors of that. Well, the factors of 32 are plus or minus 1, 2, 4, 8, 16, and 32. And I'm going to say that you would guess and check from here. You would guess 1, which I'm going to tell you doesn't work. You would guess negative 1, which I'm going to tell you doesn't work. You'd probably guess 2, and that doesn't work. What first works is negative 2, just to save some time here. I'm going to drop it low. A lot of times when you get a 0 here, it's kind of a giveaway that it works, but let's keep going here. Sure enough. So I know negative 2 is 1 already. This gives me x squared plus 16. When I set that equal to 0, I would minus 16 to both sides. I'm going to bring it up here. And a nice square root. And of course that gives me plus or minus, because I took a square root, for I. Well, there's my one and my other. Try number 8 on your own. It's actually going to get a square root answer versus an I answer, but it's the same kind of setup. Try it on your own, pause it right now, come back and check. So my possibilities are very simply plus or minus 1, plus or minus 7. I'm here to tell you that the first one does work. And there's that little indicator again, because I drop it low and I get a 0 there. And that does often end up that way. As such, this gives me x squared minus 7. Again, I set that equal to 0. I'd add 7 to both sides, and I'd square root it. X equals plus or minus the square root of 7. So I've got 1, we found that right away, square root of 7, and negative square root of 7. Okay. Your homework is the next 2 pages. It's 8 problems, and with that being said, you do not have to do number 5. Okay? Have a good day.